So you have to write a math paper. Probably the first thing that you do is you write your proof down on a napkin, the way that I always recommend that you do, just to get your ideas out of your head and down onto a page, and just to make sure that it makes sense. Once your cocktail napkin version of your proof is ready for prime time, you take the next step and maybe you write it down on actual paper with an actual writing instrument, ideally a pencil so that you can erase when you make errors. But when it comes time to actually submitting this to somebody as a finished, polished product, handwriting's not going to cut it. So you got to do some computer work and some word processing. And so maybe someone like me in the previous video suggests to you that you should type up your proof using Microsoft Word. Well, maybe that's not your cup of tea. Certainly not my cup of tea for a variety of reasons. Or maybe you're working in an office environment, like at a professional mathematics department, for example, or maybe with a team of engineers and scientists, where Microsoft Word is not part of your day-to-day workflow, and you want really spiffy, professional-looking results that look like they came out of an academic journal or a textbook. That's great. You can have those results, and all it will cost you is the steep learning curve over the next 10 minutes to get introduced to a new system called LaTeX. So typing your proof in the LaTeX environment is how mathematicians and professional scientists and engineers, it's how they do their math typesetting work. It really, again, produces beautifully polished looking documents that look like they came out of a textbook or a journal. And it's not really that hard to get up to speed with it, thanks in particular to some free online tools that exist now that didn't when I was a young whippersnapper doing mathematics. So I want to introduce you in this video to what LaTeX is, how it works, and just enough of the basics to get you started with writing mathematics in that system. Getting the basics of LaTeX down is not that challenging, but it does require a small paradigm shift in how we think about the documents that we write mathematically. LaTeX is what's called a markup language. And what that means, similar to HTML on the web, is that there are kind of two different documents. There's the document that we write, and then there's a separate document that we want other people to see. It's like the code behind the document and the document itself. So the code is what we call markup. Then there's the document, the actual thing that you would print and hand in, for example, that looks all nice. Usually that document is in a PDF format, something that's easily transportable across different systems and will always look right no matter who's looking at it. The markup files tend to be what are called TeX files, T-E-X files, extension for those. And what connects those two different worlds is an interpreter software. You might call it a compiler, a processor, a parser, whatever you call it. This is the software that makes LaTeX what it is. And only by processing our markup through the interpreter software do we arrive at a document that's readable and that we want other people to see. So LaTeX, unlike Microsoft Word, is not a WYSIWYG, what you see is what you get experience. What we have to do is we have to write something in the markup language, then let the software convert it into a spiffy looking document that we can show other people. For example, if I wanted to write an integral for, say, a fundamental theorem of calculus argument, I might write this jumble of symbols inside of my markup document. Then I feed that markup document to the interpreter, and it turns into this really awesome, nice-looking equation. And so that's what we're going to learn how to do. And while you can get an interpreter to download and install on your own computer and it lives locally on your PC, there's a great system called Overleaf, which is a cloud-based LaTeX interpreter. It's free. You can sign up for a free account and jump right in. And that's what I'm going to encourage everybody to do this semester. So let's get started by opening a fresh document in Overleaf and starting writing. So here I am at overleaf.com. If you don't have an account on Overleaf already, just register. Just give them your email address and create a password, and you'll get set up with a free account right away. If you already have one, log in, and it'll take you to your home screen. So here's my Overleaf homepage. You can see that I do a lot of my own professional work, writing materials for my classes that I teach, scholarship. I do a lot of that stuff inside of Overleaf, so this is a part of my everyday life as well at work. If I want to open just a blank file, a place to put down a proof and start to work on this, I'm just going to click on New Project over here on the side. And I'm just going to choose Blank Project. And one of the great things about Overleaf is that they also have a bunch of templates for other things that you might want to write. If you want to write a resume, if you want to write an honors thesis or a master's thesis, a journal article, a book, all kinds of other stuff. Homework assignment is a nice template here if we're thinking about using this for later for our class. And it has some sort of pre-existing elements in each of those templates that you can use. I'm just going to choose Blank Project because I just want to get a blank page in front of me and start writing up a proof. And what I'm going to do is write up a proof that cyclic groups are abelian. So I'm just going to give that the name of my project and click Create. And what happens, you'll notice, is that it loads up this thing with 3 panels in it. The leftmost panel over here shows me all the different files that are a part of my project. Notice this file has the TEX extension. It's a markup file. On the right-hand side is my finished looking document. So this is the thing that we're going to be able to download as a PDF. And then here in the middle is my actual markup. Just so that we can see it more easily, I'm going to click here to hide my file tree, and I can just see my markup here in the middle. So it's the interpreter software that turns the markup that we see on the left into the spiffy looking document that we see over here on the right. Because it's a blank document, there's not much going on in here, but Overleaf has helpfully already given me a section called Introduction. It's given me a place for a title and an author, so I can change this around however I like to. Date. Today happens to be the 8th. Now notice that I just made some changes to this markup file. This is going to be a proof. But nothing's happening over on the right-hand side in my spiffy-looking PDF. That's because the interpreter software doesn't run constantly. We have to tell it that we want to recompile this input. So I can either click on Recompile up here at the top, and it'll take a few seconds to update the file. Notice now I've got my full name here, the sentence in this introduction. Or if you do want it to update more in real time, you can change the compilation here to be auto-compile, just underneath this menu here. Click on auto-compile. I'm going to do that just for the sake of this video, so that the changes as we make them to the markup file on the left will be more or less immediately reflected in the finished file over here on the right. Once we've got this file to where we want it to be, and we want to download it as a PDF to print, to hand in, to share, we can use sharing buttons up here and or the download button here to grab a copy of it as a PDF when we're ready. So as always, I recommend that the first step in your mathematical writing be that, write. Just get your ideas out of your head, through the keyboard, into your computer, however. Think of this as the cocktail napkin version of the paper that you're writing. So I'm just going to open any old text editor, like Notepad for example, and just type in the proof that I want to type in or whatever it is that I'm trying to write up, just to get it into the computer without worrying about formatting up front. So I'll just open up a Notepad and sort of type it in here, get all of it in. All right, there's my proof. So what I want to do in this video is use Overleaf to write up a proof that every cyclic group is abelian. If you're watching this and don't know what that means, that's okay. What I'm mainly interested in is how do I get this thing that I just wrote down, however, right? So I have some mathematical ideas and notation in here, and I just used some random symbols from the keyboard to represent a few things like the operation in this group, the exponents that I want right here on this A. I've got some equations going on. So there's some math going on here, and I just sort of just put it down into a page without worrying about how it looks for the moment. We're going to take these ideas and apply the style conventions of mathematical writing to turn them into a polished proof such as you would be happy to submit to an academic journal. So how do we make that happen inside of Overleaf? Let me just take all of this writing that I did, and I'm just going to copy paste it into the markup file in Overleaf. So I'll just highlight everything, copy everything, and then inside of Overleaf I'll go to where in my document I want it to appear. Maybe I want it to be in my introduction, and then I'll just paste. And so I put a bunch of stuff down into my markup file just now. And you'll notice that Overleaf is doing something interesting. It's a little red X over here on the side. It tells me that my code check has failed. So in other words, when I write down something in markup land over here on the left, the interpreter software needs to be able to understand what I'm trying to accomplish in order to produce a polished, finished file. And Overleaf is great because it will give you little tips on how to write your markup in ways that the interpreter is going to understand. For example, when I mouse over this little red X over here on the side, it tells me that that little caret symbol that I'm using and has been highlighted here by the code checker, that caret symbol to indicate an exponent is something that Overleaf doesn't know what to do with unless we're in math mode. So that, anyway, is going to be the first step in mathifying our writing in the first place, and that is to fix your fonts, to try and get all of your math that you're writing inside of your paragraphs into the math environment inside of LaTeX. So let's get all of our mathematics into math mode so that the LaTeX interpreter knows what we want to be notation and formatted like notation with italicized variables, non-italicized everything else, appropriate spacing around operators, all that wonderful stuff. Let's mark that stuff off inside of our markup file so that it knows what's math notation and what's just purple prose that surrounds it. In LaTeX, the way to denote math mode is using dollar signs to delimit them. It's like using dollar signs as like parentheses. Anything that's in between a pair of dollar signs gets treated like a mathematical notation. It becomes part of math mode. So LaTeX will format anything between a pair of dollar signs as though it were an expression or an equation. So let's go into the markup file, find everything that I intended to be math, and put it inside a pair of dollar signs. So what did I intend to be math? Well, the first obvious target is this G, comma, star thing. That was probably math notation. So I'm going to put it inside of a pair of dollar signs. Now when the interpreter reads this, it's going to know that that's intended to be math. Let me skip ahead to this a to the power m. That was one of the places where the code check was failing, because exponent notation always has to happen inside of math mode for LaTeX. So I'm going to skip ahead and surround all of those with my math mode dollar signs as well. Dollar sign, dollar sign, dollar sign, dollar sign. Okay, and once I've gotten all of those inside of my dollar signs, if I give Overleaf a second to catch up, if I just sort of pause and don't type anything for a second, it's going to try compiling my file again. And this time, you'll notice that it succeeded. The code check is no longer failing, and we actually have something over here on the right, which looks like it might be plausibly mathematical typesetting. If you want a closer look, you can just grab this divider bar here, maybe hide my markup for a second, and so I can see that, yeah, actually this is looking pretty nice at this point. There are some flaws in it still, but that's what we're going to work on next. So in particular, one of the flaws that I'm seeing in this is that I'm saying here G and H are in G, and probably what I intended there is I intended to use the element symbol to represent that relationship. So I want to get that element symbol in between the H and the capital G here. So how do we get symbols inside of our markup? This is the place where the learning curve is definitely the steepest, because in order to access any symbols inside of a LaTeX markup file, we have to use what are called backslash commands. So it begins with a backslash and then the name of the command or the symbol that we're trying to implement there. So for example, for the element symbol in a group, that little weird funny looking E thing, the command is actually backslash in, so backslash in. If I write that inside of here, then, again, after the interpreter runs once again, now I actually see that little element symbol showing up right there next to the capital G, the way that I wanted it to. So that's our first example of a special character that we can access inside of the LaTeX environment using a backslash command, backslash in for the element symbol. Do that in the other places where I intended for it also, and now I've gotten those looking the way that I want them to. So you might say, well, how am I ever going to know what all of these commands are that I might ever need to use? And the best advice I can give is to look them up as you go. If you want a symbol and you're not sure, you don't remember what it's called, there are some great sort of quick references online that you can use. One great quick and dirty reference guide, it's just back and forth of one page, can be found on my website at mathematics.com/latex.pdf. It's a nice little cheat sheet that tells you a little bit of the most popular things that you'll need to do inside of LaTeX and how you write commands to make those happen. For example, a lot of the math mode symbols that you would ever need are found down here. One more thing I'm going to do inside of my proof is I'm going to replace those stars that I'm using for the group operation. I'd like to replace those with little, centered dots on my line, just so it's a little bullet instead of a star. So there the command I want is \c dot for centered dot. So I'll go in here and change those to C dots. C dot right there, C dot there. Make sure to leave a space after C dot before you write H, otherwise it's going to blend in that H with your command name, and there is no C doth inside of LaTeX. C dot. And this needs to be a C dot. And there's a couple more, actually I think just the one more right here. So now that I've fixed all of those, the compiler runs once again, and I can double check, yep, I've got all the dots in where I need them to be. There's one more thing I need to format properly, this Z in my argument. That really needs to be the Blackboard bolded symbol for the integers, right? It's a big Z with a double bar in it. So back to my quick reference to try and find the command for that. The bad news is that it turns out that that symbol for the integers is not actually part of standard LaTeX functionality, so you won't find it in this little quick reference guide. The good news is that simple functions like that have been added back in to the LaTeX interpreter using what are called packages. And there's just tons of packages that are part of Overleaf's functionality that you can plug in to add functionality to what's already there. So to get that symbol, what I need to do is go to the top of my document, somewhere before the begin document command, but after the first line up here where you declare the document class, and use a \use package. Overleaf helpfully lists, very briefly here, some of the more common packages that you might add in. The one that I want is called AMS-SYMB. So it's a set of symbols that the American Mathematical Society have developed into a package that we can load into Overleaf. So I'm just going to click to add that. Notice AMS-SYMB gets surrounded by curly braces here. And after I've loaded in that package, now I can go into this Z, which I want to turn into the double-struck blackboard bolded Z that characterizes the set of integers. And I'll use the command mathbb, bb for blackboard bold. So \mathbb, and then in curly braces, a Z. So that's the command. In fact, it's more than a command, it's a function. Right? MathBB is a function. We're feeding it the letter Z, and so it's saying, please blackboard bold the letter Z. And now when I look in my document, I've got the blackboard bolded Z symbol for the integers sitting right there. So every so often, you might need a function like that that's not part of standard LaTeX. There's probably a package for that. It's kind of the catchword in the LaTeX community. There's a package for that, pretty much always. So after we've got our math into math mode, the next step in our process is to decide which of those pieces of math are important to display in their display math mode as a line in and of themselves, as opposed to living within a sentence within a paragraph. So which bits of math are longer, more consequential to our argument, such that they should stand alone rather than being a part of a sentence? What do we want to keep in line, and what do we want to turn into display math? So again, display math is usually the best idea anytime we're writing an equation, so it has an equal sign in it, or anytime that there's a long enough mathematical expression that we wouldn't want it to compete with other sentences in the paragraph for attention. So when I look through my argument, probably the most obvious place is this long g times h equals a to the m times a to the n equals a to the m plus n. That's a big long piece of my argument. And when I look at how it appears right now, it's all just sort of sitting out here on one big long line. So to fix that, I'm going to write that as display math. And where mathematics mode is entered by a single pair of $signs in LaTeX, display mathematics just uses a double $sign at both ends. So if I want to turn this bit here into display math, I'll just turn it into a double $sign at the beginning and a double $sign at the end. And once I've made those into double $signs, and the interpreter has done its work once again, now you'll notice in my document that that lives as display math. It's a line of its own, and it has proper spacing before it and after it to set it apart from the rest of the argument. So decide what you want to be display math, and put a double $sign in front of it instead of a single. I'll do that for this one here also. Now before we're done dusting up our notation, I want to point out one other thing that happened along the way here. Notice that I had an exponent of m plus n that I was intending right here. It's supposed to be a to the power m plus n, but the plus and the n didn't end up in the exponent with the m. That's important. So LaTeX needs to know, when I'm making an exponent, what all needs to be upstairs in the exponent and what stays down on the base. So to get this plus n up in the exponent with the m, what I'll do is I'll go back into that place in my markup file. So I can find that right here. Notice how I've written it, a exponent m plus n. And what I need to do is group the m plus n together. And the grouping operators inside of the LaTeX language are the curly braces. So I'll put a curly brace around the m plus n. And now when the interpreter does its compiling once again, we should see that exponent correctly displayed. That happens also down here. So I'll do the same thing for that m plus n. And also this n plus m that comes after it. So if your exponents are not showing up where you need them to, it's probably because you're not surrounding the exponents in curly braces. When your exponent is only a single symbol, like a to the power m or a to the power n right here, then LaTeX will understand that it's just that one symbol that goes in the exponent. But anytime there's more than one symbol that you need upstairs, put it in those curly braces. Now that we've gotten all of our math notation squared away, the last couple things I want to do are make sure that my sections of this mathematical writing are clearly delimited, and that also I'm using as short a paragraphs as I can get away with to make the point of the writing and make each individual idea easier to follow. So let's go back and look for the sections in this writing and then demarcate them with boldface headlines. So at the very beginning of my writing here, I state a result, and then the rest of it is a proof of that result. So I should make sure that those two things are separate, so the reader best understands the function of each of those two things. First of all, notice that even though I've put a line break at the end of this, so between abelian and the word proof here, there's actually a return, right? That doesn't actually show up in the finished document. That's because in order to get things onto separate lines inside of LaTeX, we need to separate them by a line of white space. So I'm going to add one more line of white space in there. And now when the compilation happens again, you'll notice that I've begun a new paragraph. Also notice that the indentation LaTeX uses by default to begin each paragraph is that it indents things by a little 1/4 inch there. Maybe that's what you want, maybe it's not. But I do want those things to be on separate lines. I should also say what this statement, every cyclic group is abelian, I should elevate it to the level of, I don't know, a theorem, or maybe a claim, or maybe a proposition, or maybe a lemma. Again, what I call it here is a signal to the reader of its importance within the larger framework of the paper that I'm writing. Since this is the only thing in this particular document, let me call it a theorem. Why not? But when I write one of these little signifiers, I want it to be set in boldface so that readers understand that that's what it's doing there. In LaTeX, the way to get boldface is to use, again, a command, a / text BF, BF for boldface. And then afterwards, a set of curly braces around the thing that I want to be bold-faced. So here it's the word theorem and the colon that comes after it. So by using this text BF command, now in my document, you can see the word theorem here at the beginning of the line has been set in boldface. I'll do the same thing for the word proof here, which is my signifier that I'm starting the next section of my argument. So now that I've got those sections set apart, and by the way, you can also use LaTeX built-in sectioning commands to help out with this for the top-level organization. So maybe I'll call this the main result of the thing that I'm writing, rather than an introduction. Then LaTeX will put it in as the name of a new section. And then the last principle is to look for opportunities to make your paragraphs as short as possible, so that each paragraph is a self-contained thought. And anytime you shift onto a new thought, consider starting a new paragraph. Journalists, when they write newspaper articles, will often have very short paragraphs because the communication is much clearer. Even if it's only 1 or 2 sentences, every new thought that comes up, make it into a new paragraph. That's how mathematical writing tends to economize. So if I do that, I'm going to look for opportunities in my proof. So let G be a group. We want to show that for all G and H we have this equation is true. That seems like a self-contained thought. So I'm going to start a new paragraph after that line. And remember, again, we need a whole line full of white space to separate things from one line to the next line inside of a LaTeX document. So don't just put one line because it'll just keep going. So I'll do that in a couple other places also. Maybe I'll do that here as well, because I've ended my application of the definition of cyclic group, and then I'm going to start making a new argument. So I'm going to make that into a new paragraph as well. And then I'm saying here at the end, completing the proof. By the way, there's one other sort of ugly thing going on here. I've got this line here after my display math has a little comma, because this math is part of a sentence, right? But we don't want to start a line with a comma. So I'm going to take this comma and just move it up here next to the G inside of the display math. So to do that, I'm just going to move the comma from outside of this double $sign over to the inside of this double $sign. Then I'm going to put in something here that indicates my proof is over. I'm going to put the letters QED, quod erat demonstrandum, which is what we wanted to prove. And again, because that's part of my sectioning, I had the word proof written in bold here. I'm going to also have QED written in bold. There are other ways that authors use to symbolize the end of a proof, like a filled-in little black square or something like that, but something that indicates that the proof is concluded and the next thing is going to be moving on with our life is something that we want to do. So that's as much tweaking as I want to do to this. Now it looks like it's in a pretty nice format where I've got paragraph breaks, all of my math looks really nice and spiffy, the longer bits of math are on their own lines in display math by themselves, nicely centered. So this looks like something I want to hand in. So I can do that either by clicking Share inside of Overleaf. If I turn on link sharing for this, then what that will let me do is share this link, so copy and paste it with anybody else that I'd like to see it. If you share the view link, the second one here, then anyone that has this link will be able to click and see both your file and also the markup code in it. So for example, if you're handing in a proof portfolio or something and you want me to see it, but not be able to edit it, then you would use this link. If you use this link, then anybody with this link is going to also be able to go in and make changes. So maybe you and your group are all working on writing up something together and you all have Overleaf accounts. Then if you share this link with your group teammates, then all of you that have this link will be able to go in and edit the same document. That's really where the power of Overleaf begins to come in, because not only can you edit documents in the cloud, you can also collaboratively edit documents in the cloud. So just by sharing these links, that's one way of giving people access to your finished document. Of course, if you don't want them to see your code, or maybe the people you're sending this document to don't care about your markup, they just want to see the finished product, then you can just download the finished copy as a PDF. You can do that from this Download PDF button up here. Do that, and what you get is a PDF document that's all nice and ready for printing. So LaTeX really is worth the investment if you foresee typing up a lot more stuff that you want to look really professional in science, mathematics, engineering, or technology. And in particular, if you're going to be going into a segment of the workforce where this kind of professional document typesetting tends to happen a lot, like high-powered R&D sector, graduate school, professional mathematicians, professional statisticians, scientists, this system is used all across the academy. So the longer that you're in a university environment, the higher are the chances that you're going to be working with people who use the LaTeX language to typeset their math. So there's a bit of a learning curve to get up to speed, but hopefully this video has helped you to do that.